2.6, 1 and 0. So you may think this is going to be a really easy lesson because 1 and 0 are pretty easy to work with. But 1 and 0 both have pretty funky rules. Some people have even devoted their life's work of study to 1 and 0. I'm not asking you to do that yet, but we do need to understand some basic principles about 1 and 0 because they do come up all through the study of algebra and math and beyond. So let's start with 4 easy problems you've seen and done many times before. 5 plus 0. Okay, 5 plus 0 is 5. 5 minus 0. 5 minus 0 is 5. 5 times 1. 5 groups of 1 or 1 group of 5 is 5. And 5 divided by 1. 5 divided into 1 part is 5. So the point of these 4 problems is that I'm adding, I'm subtracting, I'm multiplying, and I'm dividing, and I'm getting the same outcome of what I started with. I started with 5, I did something to it, and I ended up with 5, right? Right. So what this is called, to put a name to it, is it's called the identity property. Okay, and down here you'll see it again, identity property. It's all about 5's identity. What is 5's identity? 5. That's how I remember it. So to be specific, the identity property of addition and subtraction mean that if I start with a number and I add nothing, or I add 0, or I start with that number and I subtract 0, I will end up with the same outcome. So I'm going to write this in algebra. X being any number. X stands for any number in the whole wide world. Positive, negative, decimal, fraction, 1, 0, a googolplex. Any number is X. If I take X and I add 0 to any number, I will get what? Think about it. Think about it. X. I'll get the same thing I started with. Same goes for subtraction. I start with X and I subtract 0, I will always get the same outcome that I started with, X. Okay, so another vocabulary word is called the additive identity. The additive identity is saying, well, the additive identity is 0 because this number is what I am adding to X to always get X back out. It also is the same for subtraction. You still call it the additive identity. It's a little complicated to explain now. So it's that I take this additive identity 0, and when I subtract it from X, I still get X. Okay. So now, what's the difference of the identity property of addition and subtraction and the identity property of multiplication and division? Well, when it comes to multiplication and division, suddenly I have a different number I'm using. I'm not using 0 anymore. Now I'm using 1. So my multiplicative identity is 1, just to jump to that, whereas my additive identity was 0. Well, why is my multiplicative identity 1? Well, that's because if I take any number, now I'm going to choose a different letter. Let's choose A. If I choose any number, A, and I multiply by 1, I will get that same number out. Just like I did up here, 5 times 1 gave me 5. Well, A is any number, a decimal, a fraction, positive, a negative. If I take that number, I multiply by 1, I will get the same number out. Same goes for division. Start with a number A, divide by 1, I will always get the same thing out, A. Maybe not as fancy, but I should. So those are your vocabulary words for that section. Okay, now there's one other principle we need to think about. And this one's called the 0 property. Can't see it, but it's written here at the bottom. Move this out of the way. Okay, so if I have 5 times 0, I get what? Is it 5? Think. No. 5 times 0 says 5 groups of nothing. 5 groups of 0. That's 0. In fact, anything times 0 is 0, right? 10 times 0 is 0. Negative 25 times 0 is 0. Anything times 0 is 0. Okay, well, how about division? If I have 0, I have nothing, divided into 5 equal groups. If I have nothing divided into 5 equal groups, I will have nothing. So 0/5 is 0. And 0 divided by any number is going to give you 0. Okay, now moving to the next one. Now all I did here was I switched from 5 times 0 to 0 times 5. Do you remember what that property is called? Commutative. They switched places, and guess what? They're going to equal the same thing. This one's saying 5 groups of 0. This one's saying 0 groups of 5. In either case, I'm going to have 0. Because 0 times anything, or anything times 0, is 0. This last one's a little bit of a doozy. I'm going to put it in red. Because this one is doing division the opposite way that I did here. Division does not have the commutative property. It means you can't switch the order. You're not going to get the same thing. Here's a little side note. If I have 8 divided by 2, I get 4, right? But if I switch the order there, 2 divided by 8, do I get 4? No, I get 1/4 or 0.25. So these cannot be switched to get the same outcome. The outcome is actually different. So here I'm not going to get 0 again. And in the book, Linus will show you that you get a different outcome. 5 divided into no groups at all is actually undefined. It's impossible. And you will play around with this during the lesson. Okay, so the 0 property, let me extend the page here. The 0 property is A being any number times 0 equals 0. The 0 property is saying I can take A and multiply it by 0 and I will get 0. Any number but times 0 is 0. And the 0 property really doesn't have to do division, but I wanted to put it in there because of that really special, whenever you have 0 in the denominator, it's undefined. 0 in the numerator, hey, that's okay. 0 in the denominator, not okay. Okay, so here are the kinds of problems that you're going to encounter in this lesson. This will be at the end of the lesson. So they have A times 1. They want to know if you take any number A and you multiply it by 1, remember that parentheses with no symbol in between means multiply. What am I going to get? A. I'm just going to get A back out. So when I take A times 1, I get A, and that's what they're looking for. Now how about this one? 0 times R times A times D, or 0 times rad. What would that give you? 0 times R times A times D. Well, guess what? That one's going to give you 0 also, because that one is saying that 0 times whatever this big product is 0. It doesn't matter where 0 falls in the mix. If you're multiplying and there's a 0 in there, you will still get the big goose egg, 0. Okay, look at number 3. This looks like complicated algebra, but let's think about this. 0 divided by y. Y can be any number it wants, but the minute I have 0 in the numerator, that makes this whole fraction turn into 0, because that's saying 0 divided into y equal groups. So that's 0, because no matter how many groups it is, it's still going to be 0. Now plus, I'm going to recopy. Now if I have h divided by 1, I'm just going to get h back out. And now if I have 0 plus h is equal to h, because of the additive identity. Looks tricky, but the answer here is h. Okay, next one. J divided by 0. Okay, when I see this problem, the hair on my arm stands up, believe it or not. And you may not feel that way yet, but you will. When 0 is in the denominator, it's undefined. So g divided by 1 actually does give you something. G divided by 1 gives you g. But j divided by 0 is undefined. And since part of this is undefined or impossible, that means the whole thing is undefined. And my pen is running very slowly, so the whole problem here is just undefined. Or I think he uses the word impossible. Either one is okay with me. But that's going to be my answer if my pen ever finally circles this. Okay, so what starts out as an easy lesson becomes a little bit tricky towards the end. So do the best that you can and be careful, and be sure to ask questions in class. Okay, bye.